I want to see if I can just, like I used to tape off here and then upload it to Google Classroom. So, and my camera from yesterday I see is a bit flat, and I had to go and fetch a memory card and what. But anyway, it's not going to work. Okay, so did everyone try page 110?
Yes.
Huh?
Yes.
Okay, so should we do that first and then polydactyly?
Yes, ma'am.
All right. So 110.
Ma'am, are you going to present this on the board?
Sorry?
Are you going to talk to the answer to present on the board?
I'm going to write here now. Yeah. Okay, so basically, so I just wanted to show you we're going to mark that. We're going to mark the extra polydactyly. I couldn't remember yesterday if we'd gone through all the Huntington's. I've abbreviated HC, but they abbreviated Huntington's disorder. Okay, so we're going to look in the worksheet, page 6. If we've done all of that, we're going to get on to sex determination, which is like 5 minutes. Start, sex linkage, okay, and then pedigree charts, but not all today. I'm just letting you know what we're going to be doing. All right, so turn this off. Now, high-tech acoustic block. Okay, page 110. So the whole thing is that you mustn't get confused between the problems. So now we're going back. So page 110, question number 1. In certain rabbits, black fur is dominant over white. Okay? Black fur is dominant over white. And you always use the letter that matches the dominant trait. Okay? Or else they might tell you to use another letter. But generally it's the dominant trait. The offspring from a number of crosses between the same two parents were counted. There were 20 white rabbits and 66 black rabbits. Alright? A. Determine the ratio of black rabbits to white rabbits. What is it? Put it in the ratio. Black to white. How many black? 66. How many white?
20.
Okay. Work it out for me.
I've got 33 to 10. I've got 33 to 10.
I do. No, that's right. Huh? Oh, you got the answer. Sorry, I couldn't hear. Yes?
I said 33 to 10.
33?
To 10.
33?
Yeah,
3.3?
No, 33. She said to 10.
Oh, okay. I just...
Can't do decimals in a ratio.
Yeah.
Yeah, I know, but then you can round it up. This is bio. We're not going to get complex.
Oh, it does not so complex.
Okay, bio, make it simple. So how many times does 20 more or less go into 66?
So
3.
So nearly 3.3. Okay, not maths, we're not going to penalize you if you say I had 3.3s to 1. Okay, it's nearly 3. Isn't that significant to us as geneticists? Okay, let's see. What typical phenotypic ratio do these numbers represent? If you get a ratio at the end of 3 to 1, what does that tell you immediately about the parents? They're both carriers, yes. It represents the cross between two heterozygote black rabbits. Yes? Okay, the parents are both heterozygous.
No, is that not the answer to C?
So, B. What typical phenotypic ratio do these numbers represent? Typical, so I'm thinking they want to know, if you get 3s to 1, that's typical of having parents who are heterozygous. Yes?
No, because they asked for what the parents' phenotypes would be in question C.
Oh.
I said that the ratio in question A would be 33 to 10.
Sorry?
I said the ratio in number A would be 33 to 10, and then in B, when they asked what phenotypic ratio, I said 3 to 1.
Yeah, I actually left out B, I did it all in one. Okay, so I agree. So so that ratio is, what did you say, yeah?
33 to 10.
Right. And then when you simplify it further, then for B, you get 3s to 1. And then C, is that okay? All right, I just lost my pen there somewhere. Okay, I'll look for it later. Okay, so use the ratio. Okay, yeah, I did it all in one. to predict the genotypes of the parents. Right, number 2. A dog breeder breeds a particular type of dog that has pointed ears. Alright, so we're on page 110. Pointed ears. Okay? In these dogs, pointed ears, D, are dominant to drooping ears. Alright, I always start like this. So little d, drooping ears. My dog's got one of each. What does that make him?
I have no idea.
Okay, I think it might be, what's it called? Co-dominance, where both traits are expressed. But you don't do that. Okay, that's the part in the textbook we crossed out. The dog breeder wants to sell the pointed-eared dogs, but he has to make certain that the dogs, he wants to sell dogs that are pointed-eared. So what phenotype would he like them to be? Good. Big D is what he wants to sell. And do not have the drooping ear gene. In other words, they're not carriers. All right? I keep losing my place here. Homozygous and heterozygous dogs both look alike. Yes, we're aware of that. So if you either are homozygous dominant or heterozygous, the dogs have pointy ears. We know that. Right, how could the dog breeder find out which of the dogs are homozygous? How could he find out which of the dogs are homozygous for pointed ears and which are heterozygous? How could he find out? Big D, which ones have the genotype? Big D, or which ones have the genotype? Heterozygous. What do? So he's got these dogs in front of him. All his dogs, well, the dogs he's got are pointed eared. Okay? How's he going to find out if they are homo or heterozygous for pointy ears? Breed them with what? One with droopy ears. Okay? So, big D crossed with little d, or big D small crossed with little d. So now while I'm thinking of it, I went, because if you go look at Google Classroom, you're going to see Mrs. Florenca's file, Mrs. Page's file, and a general file. Has anyone looked? So I went and looked at Mrs. Page's lesson from June the 3rd. Please go and watch it. She was horrified that I watched. Okay, but nice. So she goes through all the terminology, and I can see that they set out the crosses a little bit differently. All right, I'll show you what she does now, and I've done it like that before, and then I just started doing Punnett squares in full and everything like that, because, that's what they want us to do. But I want to show you the way she does it as well. So please go and look at that lesson. It was taped in front of the other class. It was the first lesson when they came back, and genetics was in the cloud, their cloud. They couldn't remember anything. Okay, so please go look. It was really good. All right, and even the way she said certain things. I didn't watch the whole thing, but it's like, oh, okay. All right. Okay, so now, so what do we get? If we were asked to write down the whole cross, what would we call this first generation?
F1.
Sorry?
F1.
Okay, we're crossing them.
P1.
P1. All right, then we indicate what? We indicate the gametes. All right, now I used to do this as well. I kind of forgotten about it. Put the gametes in circles. Do I need to have 2 gametes for each year? Okay? Exactly. So you're actually repeating yourself. Like in when I mark your answers and I say, repeat. Okay, so you don't have to put them both in. All right, so I'm going to do it without. All right, so then you can do your little Punnett square, but hang on. This is so easy. So what would F1 be? Okay, what would F1 genotype be? Sorry?
100%.
100% genotype would be? Genotype. Okay, heterozygous, so we write down big D and small d. Or all of them are 100 or 100% or all of them have the genotype? Big D, small d. They are heterozygous. Because the word heterozygous, homozygous refers to what is the genotype. Okay. Phenotypically, physically, what gene do they express? What will they look like? They all have pointed ears. Alright, but we haven't answered the question yet. Okay, next one. Okay, so what will the gametes, if this is the P1, that's the parental generation, so now he's crossing his dogs with dogs with droopy ears to try and figure out which dogs are pure breeding, okay? So what are the gametes for the first individual? First parent? Big, small. So you could put them in circles. What are the gametes for this individual? All small. Okay? So then you could show the fertilization. 1, 2. So big D, small, small. So what's the first genotype that could be in the offspring? So all I haven't done is put the second one. Okay, so what will this genotype be? Big, small. Next one? Sorry? Guys, you need to shout. Okay, next one? Small, small. Louder.
Small.
Yay. Okay, so F1 genotype. What's the ratio? One what? Big, small is to? Small. Okay, I'm still on the board. Okay, but phenotypically, 1, or you could say 50%, 1 what? Pointed eared dog. So half of the offspring should be pointed eared, and half of them should be, or have droopy ears, droopy eared dogs. Okay, we need to say something. So what's the answer to this question? Now you've got to explain. So, when he crosses the dogs with droopy ears, which dogs is he going to choose to breed with? When he crosses the dogs who have his pointed-eared dogs with droopy-eared, supposed to be droopy ears. When he crosses his pointy-eared dogs with droopy-eared dogs, which pointed-eared dogs is he going to use to breed?
The one who's less and has no droopy ears.
Yes, because all of them are carriers, and they got that gene from the droopy-eared dog. He crossed his pointy-eared dog. Then he knows, oh yes, those ones are the ones I'm going to breed with. Because if I'm a breeder, I only want to breed homozygous dogs, to get homozygous dogs, so that I can sell them for lots of money. Yes? Can you explain that though? Can you write it down? Are you sure? Okay, you know what I would do? I'd go and find the dog with this. Doesn't bug me. Okay, all right, so that's for breeding purposes. So once you've done all of that, you need to go back and explain. All right, so let's just see if you answered the question. How would the dog breeder find out which of the dogs are homozygous for pointed ears and which are heterozygous? He will cross them with what? What did we say? He will cross them with? Dog with droopy ears to see what the offspring have. All right? Sorry, I think this might be in the way. Okay, so we've used diagrams to explain our answer, but hang on. So which one is he going to use? If he finds that all the offspring have pointed ears, then he knows that the pointy-eared dog he bred with is? And he will use that one. Must I say it again?
No.
Okay, so that's a test cross. All right, Emily, happy?
Yes, ma'am.
Okay, it's good sound today there. Okay, guys, so that's quite a nice example. It's set out in a nice way. All right, so let's have a look at this polydactyly. Okay, so hang on, let's just slow down. This is a normal dominance recessive are normal, dominant, recessive crosses where in order to get the dog with this recessive trait, you need both parents to be carriers. Alright, so normal, dominant, recessive. But now with this one, we're looking at, we're still talking about a gene that is found on the normal chromosomes. What are they called again? Autosome. So this gene about droopy-eared or non-droopy-eared is also on an autosome. Alright, but when we move on to polydactyly or Huntington's disorder or chorea, it's also a gene, a mutated gene found on a autosome, but the gene that causes the disorder is what? Dominant. Okay. Guys, the fun stuff is going to start later today. Right, so I see some of you looking tired already. So we're going to start hopefully with 6 linkage. That's the fun one. Okay, no? Excited. Alright, so this little one. I'm not going to pull it up on the screen. It's going to take me too long to look for it now. Oh, I kind of need it, hey, because of the pedigree. Okay, oh, it's in Google Classroom. Sorry, guys. Let's find it. Oops. Okay, not on. Alright, so let's go. Today's third month, 40% day actually. And I should have uploaded it. I think I uploaded it yesterday. Just check it in. Should put it in heading. There we go. Okay. In the box. Should actually switch that off now. Should give someone, guys, help me here, please. Okay, there's always planning. There's always planning. I can just use this one. Okay. So we actually do need this now. So this is a good way of introducing, oh, I didn't realize that yesterday. So you kind of been shown a pedigree and you didn't know what it was. But did you manage? Alright. So instead of just having word problems now, we now introduce something called a pedigree chart. Alright, and they give you a little key. So females are round and males are represented by squares. Alright, I have no idea why, don't ask me. And then, yeah, they've indicated that normal females, males and females are not coloured in, and that affected males and females are coloured in. But in the 1 year, they swapped that around and confused everybody. So just keep that back in your mind somewhere. Read what they give you first. Okay, alright, so provide a key. Okay, so hang on, let's read here. Polydactyly is a medical term used to describe extra fingers on the hands and toes of the feet. There they've given it to you. It's an autosomal dominant trait. So it is a mutated gene on one of the autosomes. I mean, we can go and look up to see if it's number 1 up to 22. You can go and look it up. Alright? But it's an autosomal dominant mutated gene. Okay? Right, study the family pedigree and answer the questions. Provide a key to express the alleles first for normal condition and someone affected by polydactyly. So you've got to indicate clearly, rather write, if they don't have ABs, the same. Normal is what? So if a person is normal and does not have 6 fingers and toes, small, did they tell us what to use here? No, they didn't. Okay, so yes. So small, let's just finish this and then we'll have a bit of a break. And a person with polydactyly So normal have got to have two recessive genes.
But don't you just need to show one?
Yeah, it only asks you.
Oh, the alleles, you're right. Yes, you are right. Okay, thank you. All right, so normal, and then someone who's got polydactyly has the gene PEGP. Okay, let's take a break and then let's switch that off. Do you want to go walk outside for 2 minutes?